Hi everyone, I'm Chan from Group 1 and today I'll be presenting our mini group project. The issue we are addressing is the continued use of traditional on-premise servers, which come with several key challenges. The first issue is server aging and outdated hardware. As we know, with concepts like Moore's law, computing performance improves rapidly over time, while software and system requirements also become more complex. As a result, older hardware often struggles to keep up with the newer applications, whether due to compatibility issues or simply insufficient performance. The second issue is scalability, where upgrading traditional servers is both costly and time-consuming, as it involves in purchasing new hardware, assembling it, and maintaining it. In environments where only a single server, upgrades may also require system downtime, which is disruptive and not ideal. The third issue is network bottlenecks. While networks can be upgraded, this often requires servers that are capable of handling higher throughput. Additionally, having a single point of access means all traffic is directed to one server, especially during peak periods. This can lead to congestion where the server is only able to handle a limited number of requests at a time. So here comes the question of why we should use cloud servers. First, it is scalable. It overcomes the problem of upgrading hardware. It means that resources such as computing power and storage can be increased or decreased as needed. Secondly, it is cost effective. We no longer need to invest heavily in new hardware every few years in order to keep up with demand. Third, cloud platforms offer high reliability. Since data is backed up across multiple servers, even if one node fails, the data remains available elsewhere. And finally, cloud services are flexible, allowing services to be turned on or off based on demand, following a pay-as-you-use model. After understanding the benefits, the next question is, which service model is best? So there are a few cloud-based designs to choose from, namely infrastructure as a service, platform as a service, software as a service, and that's about it. Infrastructure as a service is the best choice as it provides the highest level of control. This is important because the university wants to host and manage its own applications and services. In comparison, platform as a service and software as a service are more suitable for non-technical users who simply want to use application without managing underlying infrastructure. Finally, what are the main components of an infrastructure as a service solution? Using Huawei Cloud as an example, infrastructure as a service provides virtualization and virtual machines, such as elastic cloud servers, storage services for both structured and unstructured data, load balancers to distribute traffic and ensure high availability, backup and recovery services to protect data and ensure business continuity. Here is the architectural diagram, and as you can see, the cloud provider provides load balancing, application and compute, as well as storage and databases. The rest of the infrastructure is provided by the university themselves, which includes the end devices, access and network, as well as the on-premise servers that the university currently has. There are a few risks of migrating to the cloud, namely data security, privacy, outages. These three are the main things that we focus on when we talk about cloud risks, as outages can randomly occur either due to human error or natural causes, and data stored on cloud servers could be breached and have unauthorized access if the cloud provider does not have the necessary security measures. A rather notable outage is when AWS went down in 2025, causing more than 1,000 businesses to be affected, which include major businesses like Canva and Snapchat. So it could happen at any time and anywhere. With that being said, these risks can be effectively mitigated through appropriate cloud design strategies, such as using elastic load balancing and elastic cloud servers offered by Huawei. The deployment of these services across multiple availability zones eliminates single points of failure. Retaining sensitive data on-premise in a hybrid cloud setup also offers data security when it comes to sensitive data. So in conclusion, to remain competitive with modern digital services, migration to the cloud is increasingly inevitable. The benefit it provides, such as scalability, reliability, cost efficiency, and flexibility, far outweigh the associated risks with mitigation measures in place. Thank you for listening.